Hey everybody, we're back again. It's me, Amy, the MA mentor. How you doing? So today we are going to talk math. Sorry. Um, Please, as always, if you like the content that I bring you and it's helping you at all, I hope it is. Please click the like and subscribe buttons. It really helps me out. And we're going to dive into this now. So here we go. Okay, so math. Math is a crucial part of our job as medical assistants. I am sorry. For those of you who like math, power with you. I'm a math person too. But sadly, there's so many of us that are not good with math, are a little scared of it, possibly a little intimidated by it. But trust me, it is not that bad. It is nothing to be scared of. And today we're going to talk about dosage calculations and how we actually do all of this so that we can do our job effectively. Also, so that we can, keep our patients safe and administer the medication that needs to be administered safely and accurately. Okay. So first and foremost, let's go ahead and take a look at just some math basics. Okay. Um, Math basics include things like, well, for our purposes anyway, include things like decimal points and understanding how to round and places and things like that. Things we probably learned when we were in grade school, but probably haven't used all that much or haven't really even thought about. So just really quickly here, when we're talking about decimals, we have places, right? There's places in front of the decimals, which we call whole numbers. There's places behind the decimals, which are basically fractions, okay, or part of a whole number. So we generally don't go out any further than 1,000 in the medical field. So I didn't go any further than that, but we have thousands out at the beginning here, thousands, then hundreds place, and then the ones place. So basically going from largest over to smallest, from left to right, towards the decimal point. Once you get to the decimal point here, then the opposite side or the right side of the decimal is where all of the fractional or parts of the whole reside. And again, we don't generally go beyond thousands with that either. So looking at that, we have the tenths, the hundredths, and the thousands. And I always laugh here because yes, there is no such thing as a one-th. You can't have a one-th of a whole. You can have a tenth of a whole. Can't have a one-th of a whole. Okay. So that's why it starts with tenths. Okay, then when we go to rounding, we do have to round oftentimes when we do dosage calculations because let's face it, not everything comes out exact or even. Okay. This is no truer than when we have to do calculations for pediatric patients, because oftentimes we calculate dosage for children by weight, and that is definitely never even. And we'll go through how to do that here in a little while. But just to remember rounding, I've got a couple examples here, but just remember that we round up if the number we're looking at is greater than 5. And if the number we're looking at is less than 5, we do nothing. So let me just show you what I mean there. So let's take this first one. It's 12.5436. Could come up when you calculate a dosage. Let's say we need to round to the hundredth. Okay. So the hundredth is what I have bolded here. That's the 4, because if you look up here, this is the tenths, this is the hundredths. Okay. That's the number we want to round to. That's the number that's going to do something. Okay. Or we're going to do something with, rather, I guess. So really then, in this instance, and in any instance really, once we determine which place we're rounding to, the number to the right of it is the only number that we're concerned with at that point. There could be 100 numbers behind it. We're only concerned with the one that's right next to the number we are rounding to. Okay. So in this case, since we're rounding to the hundredth, This is the number we're concerned with, the 3. Okay. Now, let's go to our rule. What does it fit? Is it greater than 5? No, it is not. It's less than 5. So since it's less than 5, we do nothing about that 4. We leave it as is, and we just drop everything behind it. So what we come up with then is 12.54. Okay. Here's another one. Okay. 1.27598 rounded to the 10th. As we can see, the 10th place has a 2 in it. So that is the number we are going to do something to. And so we are only concerned with the one right next to it, which is the 7. It does fit in that it is greater than 5. So we know that if it's greater than 5, we round up. So we are going to then take that 2, turn it into a 3, and drop everything else, which gives us 1.3. Okay. If there is no whole number, and this is super important too, a lot of people don't think about it. If there's no whole number, so you just literally just have a portion or a fraction of a number, put a 0 there in front of the decimal point as a placeholder. And I'll tell you why that is. Not so much anymore because we live in an electronic age where we have like electronic prescriptions and things like that and electronic orders. But back in the day, which I love to say because I'm old. No, back when I first started in this industry, we hand wrote everything. And there's still places that do handwritten orders and handwritten prescriptions. Not that many, but if you find yourself working in like a rural area or something, you could very well see that. Um, and the big joke always, has been, you've got doctors' handwriting, right? And it's true. Doctors do not write well. So if you just were to put 0.25, let's say, and not put that 0 in front, number one, it's very possible that somebody might think that you're leaving something off because there's nothing there. Or if the handwriting is just atrocious, you may not understand what's there either. So always just put a 0 there in front of the decimal point if there is no um, whole number. So for a quarter of something, a fourth is 0.25, right? If we were going to type that out or write that out, we would want to put 0.25. So it's very, very accurate, very clarify, that that's exactly what that number is. All right, so moving on, the metric system. Okay, so let's talk metric. The metric system is a system of units, so a system of measurement that is used in pretty much every single part of the world except the US. Which is why in the medical field, we make sure we use the metric system because it is universal. So it doesn't matter what country you're in, what country you're from, what country your colleagues are from. This particular system of measurement is going to be the same no matter where you go. So it's a universal language of measurement. What I have here for you is kind of a little, I don't know, it's a little graph, not a graph, a chart of the various units of measurement that we use in the metric system in the medical field. If you're thinking back, if you're looking at this right now and you're thinking back to like, I don't know, God, when did we learn this? Middle school? Maybe high school? I don't know. And you're like, wait, there's a bunch of them missing. There are. There are a few missing here, only because they're ones that we do not use in the medical field. So like deca, there is such a thing as a deciliter and a decagram and a decameter, but we don't use those. Okay. Gosh, I can't even remember it right now. It's something about a king. There was a saying to remember all these back in the day, but anywho, so what I have here is basically the 3 different types of measurement we do in the medical field. So volume, weight, and length. And then I have the various units of measurement in the metric system, going from the largest unit to the smallest unit for each of those. Not only written out, but what the abbreviations are. So starting the farthest to the left, we have volume. Now, if you look at the second one down on all of these, that is what they call a basic unit. Okay, so for volume, liter is the basic unit. For weight, it's gram. For length, it's meter. Okay, that is the basic unit of that particular measurement that all the other units are based off of. Okay, and let me explain what that means. So if you notice the very top one, the largest one is kilo. Okay, kilo means 1,000. So basically, when you put kilo in front of anything, it means 1,000 of that thing. So a kilogram is 1,000 grams. A kilometer is 1,000 meters. A kiloliter is 1,000 liters. Okay. Everything below that basic unit on this chart is a portion of that basic unit or a fraction of it. Okay. So milli, for instance, MILLI, means 1/1000th. Okay. So if you have a milliliter, it's 1,000th of a liter. A milligram is 1,000th of a gram. And yes, I'm saying thousandth. Okay. Um, a millimeter is 1,000th of a meter. Okay. Now notice on my chart, I do have one extra one in there that is centi. We don't use that in gram. We don't use that in liter, but we do use that in meter. So a centimeter. And centi means 1/100th. Okay. That will play in here in a minute. Okay. And then micro, based on the basic unit, is 1/1,000,000th. So 1/1,000,000th of that basic unit. So a microliter is 1/1,000,000th of a liter. A microgram is 1/1,000,000th of a gram. And a micrometer is 1/1,000,000th of a meter. Now, really, the only one we see in medicine is microgram. But I went ahead and added in the meter and the liter just for congruency's sake. Okay. All right. So those are the metric system. Now, let's take a look at the conversions here. How to convert this. Notice that I have 1,000 in between each of these. We're doing grams. Okay. What that means is the difference between each of those is 1,000. Okay. So if you start at the bottom, you can theoretically say, not even theoretically, actually say that there are 1,000 micrograms in a milligram. That is true. There are 1,000 milligrams in a gram. That is true. And there are 1,000 grams in a kilogram. That is also true. Okay. Bear with me. You'll see why this is important. Okay. So let's look at our conversion here. We're trying to decide how many milligrams is equal to 2 grams. Okay. Now, those of you who are smarty pants out there can go, well, if there's 1,000 milligrams in a gram, then that's 2,000. You would be correct. However, if your brain does not work that way, which a lot of people's don't, especially with math, when they're going, it's math. Okay. There is another way to look at this and to figure it out by simply understanding this chart, or what I call the ladder. Ladder like that you climb, not the after. And just moving the decimal. Okay, so let's take a look here. Okay, so here is our 2. Now here's the reason I have this here, okay? Any whole number, as we noticed before when we're looking at decimals, any whole number is going to have a decimal after it. Even if there's no numbers there yet, there's going to be a decimal after it because that's what a whole number is. It's the number right before or to the left of the decimal. So if you stick your decimal after your whole number, which is 2 in this case, okay? Let's go ahead and take a look at our ladder, okay? Because we've got our decimal place now. That allows us to move it, okay? But where do we move it? Which way do we move it? And how far do we move it, okay? So let's take a look at our ladder, okay? Here's our ladder. If you are going down the ladder, okay, so from larger to smaller on the ladder, that means you are going to move your decimal to the right. Okay, so down means right. Hope you're following me so far. Okay. If you are going up the ladder, then you are going to move the decimal to the left. Okay. So down is right, up is left. Now, the number of places that you move that decimal depends on what the difference between the two units is. Okay. So in this particular instance, the difference between our units is grams to milligrams. How many zeros are there in between? There's 1, 2, 3. All we have to do is move our decimal 1, 2, 3 places. And suddenly we now know that 2 grams equals 2,000 milligrams. That's it. I've taught math for a very long time. The most important thing to remember with math is don't make it any more difficult than it has to be. And this is not hard once you look at it this way. Okay. Let's just talk about this a little more. Okay. Notice we went from grams to milligrams. Down meant right. Number of zeros between is 3. Now, say I went from grams to micrograms. That's still down. It's still right. But now we've got 1, 2, 3, 4, 5, 6 zeros in between the unit I'm starting from and the unit I'm ending with. So I would have moved that one 6 places and gotten the correct answer. Okay. Let's go ahead and take a look at some other examples. All right. Let's look at this guy. 1.25. Now this one already has a decimal in it. So we don't have to place a decimal. It's already there. Okay. So 1.25 milligrams to grams. Which way are we going on the ladder? We're going up, right? Because milligrams is smaller than grams. So we're going up, which means we're going left. Okay, so here's where we're starting. Here's our decimal. We'll move that guy 1, 2, 3 places. And that gives us 0.00125 grams. Okay. Let's do the other one. 35 centimeters to micrometers. All right, so we place our decimal. Now here's the thing with the centimeters. Okay. In fact, let me go back a couple here. Sorry. Okay, let's go all the way back. Okay, so if there's 1,000 here, and we know there's 1,000th of a difference between the meter and the millimeter, this guy goes in there and breaks it up though, right? So if we know this is 100th, that means that there's only 100 difference here. But if we have to make up that 1,000, How many more zeros does 1,000 have in it than 100? 1. So if this difference is 100, that means this difference is only 10. Okay? Keep that in mind. Let's go back real quick here. Sorry for all the clicking. Okay, so we're going from centimeter to micrometer. We're going down, right? Down is right. But we're going from, oh no, I am so sorry. We are going from here, centimeter, to millimeter, 10. Oh, goodness, I am so sorry. 10, 1, 0, to micrometer, 1, 2, 3 more. So your 10 that's between your centimeter and your millimeter is the 1, 0. And then 3 more zeros between millimeter and micrometer. It's 4 zeros, and you get 350,000 micrometers is equal to 35 centimeters. Okay. I know it seems complicated, but literally, if you just write down that chart, my ladder, because that's how I look at it, it's rungs of the ladder. If you write down that ladder, put those thousands, and then in this case, the 10 and the 100 in between them, and literally just move one way or the other, depending on how many zeros are in between, you can do this. And if you do that starting out, eventually it's going to click in your mind and you'll be able to do it without the chart. Okay. All right. Next, we're going to talk about converting other units. Okay. We just converted within the metric system, which, by the way, why would you do it? You don't do it every single day. That's the good news. The reason you would have to convert within the metric system is for medications that are ordered one way but are only supplied another. Okay, so for instance, if your doctor said, there's one really popular one, there's an antibiotic called Rocephin that you give in the office quite often. And Rocephin is only supplied when you take the vial down, or is usually, let me back that up, usually only supplied in milligrams. That's what it says on the vial when you take it off the shelf. The doctors will oftentimes, though, order it in grams. So what you have to do before you can start to calculate that dose is you have to change their order to what you have. Okay, that's when you would have to do that. However, again, that is not an everyday thing. Okay. Now, when we have to convert from systems of measurements to other systems of measurements, as I have here, which is metric to household conversions, this is oftentimes when you have an instance, for example, you have a parent of a child and the doctor has ordered for them to take a specific amount of medication. You're educating them on how to take that medication. And because we use metric in orders, it's going to say maybe take 5 milliliters twice a day, for the child. Not a lot of people have metric measuring devices at home. Now, if you get the little cup that comes with the medication for cough syrup and stuff like that, or if you have a syringe, that'll be in metric. But if all you've got is teaspoons and tablespoons and stuff like that, that's not going to be that way. Okay. And especially since in this country, we don't use metric that often. So understanding that 5 milliliters is equivalent to 1 teaspoon can be very helpful. You can tell that parent because surely the pharmacy will hopefully put 1 teaspoon on there, but if they don't read that, if they don't think about it, you can tell the patient, here's how much you're going to give your child when you get home. Okay. So I just have a few typical volume and weight conversions here. We don't really convert length. Um, and these are, you'll notice in the volume I have three equivalencies. They are all the same. So for instance, 1 teaspoon is 5 milliliters, but is also 60 drops. GTTS is drops. Okay. Another example, 1 cup is 8 fluid ounces, but 8 fluid ounces is also 240 milliliters. Okay. So there's your household to metric conversions. So if you ever need to do that, it's very handy when you're cooking too. Just saying. On the weight side, the weight does come in very handy when you have to convert a patient's weight in pounds to a patient's weight in kilograms. Okay, and we do that quite often. All right, moving on. Let's take a look at these. Let's do some conversion. Okay. So some people, like I said, that are very math minded and can do this stuff in their head, oftentimes they just have to look at the conversion and wham, bam, boom, they've got it. Okay. Um, some people do not have that ability. So in this instance, let's take a look here real quick. So we've got 10 milliliters equaling how many teaspoons? Okay. First thing we want to do, and I write these like a fraction. First thing we want to do is take, and yes, this seems like a lot of work, but again, like with using the ladder, once you do this over and over, you'll finally click to where you can do this in your head. But this is one way that if you're just staring at it and you really can't figure it out, you can grab out a pen, paper, and a calculator and figure this out real fast. Okay. Okay, so let's say 10 milliliters, we need to know how many teaspoons that is. Okay, so first over here, I'm going to put the fraction of what I know to be true. I know that 1 teaspoon is 5 milliliters. Why? It's on my chart that way. Okay, so I'm going to put that here. I'm going to set that equal like an equation. I'm sorry, did I just scare a bunch of people saying equation? It's not an equation. It's not an equation. Just don't look at it that way. Um, I'm going to set it equal to what I don't know, what the problem is. So here's what I know. I know 1 teaspoon is 5 milliliters. What I don't know is this problem. I don't know how many teaspoons. So when we don't know, we put X as a placeholder, as an unknown, is how many is 10 milliliters. Okay. Then what I'm going to do is I'm going to cross multiply. I am going to take, and I'm not going to use the units here, just the numbers. I'm going to take 5 times x, which is 5x. I'm going to take 1 times 10, which is 10. That's going to give me this. 5x equals 10. Because 5 times x is 5x, 1 times 10 is 10. Now, I don't like to use this word either, but I'm just going to put it out there. Oh, algebra. There, I said it fast, so it didn't hurt anybody. In that particular type of math, people get really scared by the word algebra. When you get to something like this, okay, where you have 5x equals 10, as I have, it's a game at this point. The game is, and the goal of the game, the object of the game, is to get this x, this letter, all by itself. Okay. So the only way to do that is to do the opposite function of what is happening. So what did we do here to get this? We multiplied. What's the opposite of multiplying? Dividing. Okay. Because I know if I divide this number by itself, I get 1. And 1 just means x. Okay. So I'm going to do that. However, you can't, it's like a teeter-totter or seesaw or whatever part of the country you're in, whatever you call it. What you did on one side, you can't not do it to the other side. So you have to do it to each side, otherwise it becomes unbalanced, like when the big kid got on the end of the seesaw with the little kid. The little kid went whoop. Okay, that doesn't work. Okay, so what we're going to do now then is divide this by 5, because those cancel themselves out. And guess what? All we got left is x. 10 divided by 5 is, yep, you guessed it, 2. So guess what? 10 milliliters equals 2 teaspoons. That's it. And like I said, some people can do that in their head. Some people can figure that out and say, oh, well, if 1 teaspoon's 5 mLs, then double that is double. So 10 would be 2, okay? And that's great. If you can do that, beautiful. This is another way to do it if you can't, okay? Let's try this one. All right, 145 pounds to kilograms. We know, because it's on our chart, the 1 kilogram is 2.2 pounds. So now we need to know how many kilograms is equal to 145 pounds. Again, we're going to cross multiply. 2 times, or 2.2 times x is 2.2x. 1 times 145 is 145. We got to get rid of this number here. Let's divide by 2.2. That leaves us with just x. And 145 divided by 2.2 gives us 65.9. It actually does, I think it's 909090 repeated, but or something to that effect. But it does round to 65.9. Weight, by the way, always to the 10th. Body temperature, always to the 10th. Okay. All right, so that is how we do that. If you need to go back and watch that again to go through the steps, great. Otherwise, that's how you do it. Okay. All right. So now let's talk about calculating doses. Okay, here's where we get in the nitty-gritty now that we know this stuff. Okay, so for injectable medications or oral liquid medications, so either things you're going to inject into somebody or they're going to drink, okay? You want to use the following formula. Now you'll read books. If you're in an MA course right now, you probably have a book that says something along the lines of dose ordered divided by dose on hand, blah, 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 and it's got all this crazy math. Okay, there's a very simple formula here. Need divided by have times volume. Okay, and here's what that breaks down to. The need is the order. It's what the doctor has ordered for the patient. That's what they need. It's what you need to give them. Okay. The have is the dose on hand. It's on the label. It says right on the label. Okay. The volume is also on the label, and it is the number of milliliters associated with that dose. Okay. Now, if it just says ml, that's 1. Okay. But if there's a number in front of it, that then becomes your volume number that you plug into this particular formula. Okay. Let's look at what that looks like. All right. You know what? I put that in the wrong place. We're going to go forward. Just really quick. I do apologize. All right. So let's practice this. Okay. Here is cyanocobalamin. Say that 5 times fast. This is B12. Okay. Let's take a look at the label here. And this is an honest to God label. I'm sorry, it's a little fuzzy. Okay, so on this label, don't get confused by this where it says 30 mLs. Okay. If that's all it says, if it just has a number and the mLs, that means that's how many milliliters are in the whole vial. Okay. It has nothing to do with the dosage. That's what the whole vial is holding. Okay. What you want to look at is this number right here. Okay. This is telling us that for every milliliter that you pull out of this vial, there's 1,000 micrograms of medication in it. Okay. So far, so good. So this is your have. This is your volume. Okay. Here is your order. That's your need. Okay. So basically what you're doing at this point is you are taking your need, 1,500 micrograms, because that's what the doctor ordered, your have, which is this 1,000 micrograms that's on the label, your volume, which it only says ml, which that means 1 ml, and you're plugging it in to that formula, doing the math, and you get this answer. So 1,500 divided by 1,000 times 1 is 1.5. So if you drew up 1.5 milliliters of B12, you would have the correct dose that the doctor ordered. You would have the 1,500 micrograms. Because let's face it, micrograms, milligrams, those are a weight. Those are, if you were to look at a weight in a medication, it's a solid, okay? These are liquids, and liquid we know is volume. You can't take a voluminous, I guess, a volume, excuse me. You can't take a volume liquid and look at it and go, I know what the weight is here. You can't do that. That's why you have to use this formula, because you have to understand how much weight of the medication is contained within the volume of the liquid. Okay. All right, let's do another one. Here is this is something you drink versus inject. This is augmentin. It is a antibiotic. Okay. The order on this one says augmentin 250 milligrams PO. PO means by mouth. Okay. I will have another video that talks about medical terminology and abbreviations. So we're going to take a look at this. Okay, so our need is 250 because that's our order. What does our have here? If you answered 125, you're correct. Okay. And then our volume, if you answered 5 mLs, you'd be correct, because here, notice this actually has a number in front of it. It's not just ml, so it's not 1. Okay. Plug that in. Here's what we get. 250 divided by 125, that's 2, times 5 is 10. So this particular patient would need to take 10 mLs, or 2 teaspoons, however you want to look at it, of medication for this order. Okay. Now I do apologize. Let me go back here real quick. I put this in the wrong spot when I made it. I had mentioned that we talked about, or I mentioned earlier, and we talked about calculating dosages by weight. Okay. We do this with children quite often. So that then adds one more layer or another step into this process, but it's basically the same. So let me show you how this works. Okay, so here's our order. We have amoxicillin, and when you know that it's being ordered by weight, you'll see it written this way. So this doctor's ordering 10 milligrams per kilogram by mouth, meaning for every kilogram this kid weighs, the doctor wants him to have 10 milligrams of medication. Okay, so if he was 10 kilograms, he'd get 100 milligrams. If he was 20 milligrams, you get 200 milligrams, so on and so forth, okay? So this is going to now be dependent on how much the kid weighs. So we have to have the weight, and we hopefully took the weight when the child arrived, so we have that, okay? But we took the weight in pounds. So here's where that conversion comes in, where we have to convert the pounds to kilograms, okay? So if we do that, which is literally just taking pounds and dividing it by 2.2, because we ran through that a little earlier, right? Okay, you get 19.1 kilograms. That's rounded, okay, which is fine to do. So this child in kilograms weighs 19.1. And by the way, if you want to feel thinner, Um, start writing your weight in kilograms. It's lower. And that's another thing to think about too. I talk about with math not making things harder than they have to be. Also, when you're done doing a function, a problem, whatever, calculation, ask yourself if it makes sense before you move on. So understanding, and maybe you didn't before, but hopefully you do now, understanding that a kilogram weight, the number is going to be smaller than the pound weight of the same weight because kilogram is only one and pounds are 2.2 of that. Um, if you calculate and your kilogram answer is higher than your pound to begin with, you did something wrong. That doesn't make sense. Go back. Okay. Um, when you're calculating medications, and I will also be doing a video on administering meds. You will know if you do not by now that there's only so much you can inject into a patient at a time. So if you miscalculate and you're coming out with like, you're gonna inject 20 milliliters into somebody, that's not right. Okay. All right. I digress. Moving back. Okay. So 42 pounds divided by 2.2 gives us 19.1 kilograms. Okay. So now we don't have our need yet. What we're doing in this step is defining our need. Okay. So the doctor said 10 milligrams per kilogram, meaning every kilogram they get 10 milligrams. So in this particular instance, we are just multiplying. Okay. So 10 times 1 point or 19.1 is 191 milligrams. Yay, we have our need now. Now we can move on and calculate how much we're actually going to give them. Okay. So now our need is 191. Our have is, where did I find that? 400. There's our have. Our volume is 5. 191 divided by 400 times 5 gives you this number. We are just going to round it to 2.4. And here's why. This is a PO medication, so they're going to drink it. So it'll come out a little cup. Okay. If it was an injection, you would be drawing it up in a syringe. Well, no, that kid's big enough. A 42-pound kid's not going to need a syringe to take their medication. But babies, you oftentimes will draw the medicine in a syringe and shoot it into their mouth. I don't care how good you are. There's nobody that could pull up into a syringe or even pour into a graduated cup 2.3875. You're just not going to do it. So 2.4 works. Okay. All right. So again, calculating by weight, one extra step here to get your need. Then you just move on from there. And I hope that makes sense. All right, let's go past this again. Okay. We are done. And as always, I appreciate you hanging out for this video. If there's anything else you need math-wise, just drop it in the comments. Please let me know. That was kind of a basic overview, but that's really what I have found students struggle with is just those concepts. But I can absolutely make more videos on math for you if you really, really need it. I know a lot of people struggle with it. So again, thank you for watching. Hit subscribe if you haven't, and I will see you next time. Take care.